When an equation contains a power with a rational exponent, you can solve the equation using a procedure similar to the one for solving radical equations. In this case, we're going to isolate the power, so like this, and then raise each side of the equation to the reciprocal of the rational exponent. So there will be two examples. So you have x plus 30 raised to the 1/2 equals x. Now, just real quick, we have to remember that we can rewrite this x plus 30 raised to the 1/2. We can rewrite it as a radical. And remember, the denominator is the index. So really, this is the square root of x plus 30 equals x. In this case, this is nice to you could rewrite this one. But then, for example, letter B, we don't want to. So just to reiterate that we could rewrite this is the same thing as the square root of x. Okay, let's go on with this one. So 1/2, what is the reciprocal of a half? The reciprocal of a half is 2. So that's why we're going to raise it to the power of 2. Each side to the power of 2. 2 over 1, which is just 2. So notice when I do that, 1/2 times 2, it cancels that exponent out. So now we have x plus 30 equals x squared. It's a quadratic, so we're going to set it equal to 0. So let's move everything to the other side. So this is 0 equals x squared minus x minus 30. And so we want to see if it's factorable. Is anything that multiplied to -3 that adds to -1, and that is -6 times a positive 5. -6 times 5 is a -30. -6 plus 5 is a -1. So this factors to x minus 6 and x plus 5. Using the zero product property, we know that x equals 6 and x equals -5. So now we need to check. So we're going to plug it into the original. Now, it might be helpful to write it in nth root form. So looking at this example here, let's plug it into here. Remember, this is the same thing. So let's check. Square root, we'll plug in x equals 6 first. So square root of 6 plus 30, does that equal 6? So square root of 36 equals 6? Yes, 6 equals 6. So x equals 6 is a solution. So let's check the next one. X equals -5. So we're plugging it into the original. -5 plus 30, does that equal -5? You probably see already that it doesn't work. -5 plus 30 is 25. Square root of 25 minus 5. 5, does that equal -5? No, it does not. So that is not a solution. Let me do one more example for us. We have x plus 2 raised to the 2/3 equals 16. So what is the reciprocal of 2/3? The reciprocal is 3 over 2. So we're going to raise each side to 3 over 2. Now, on the left side, it cancels out the exponent. So now the left side is just x plus 2. But now we have the 16 to the 2/3. We can rewrite that as an nth root. Remember that the denominator is our index. So therefore, we can rewrite this as square root of 16 raised to the 3rd power. Again, denominator is the index. And so now we need to simplify this. So square root of 16, do we know what square root of 16 is? Square root of 16 is 4, and then now raise it to the 3rd power. Now again, just to kind of talk about this is I would do the nth root first because it is nice. It makes it smaller, and you don't have to use a calculator. Multiplying 16 times 16, you might have to grab a calculator unless you know it in your head, which is totally fine. But it's nicer to make it smaller first and then, raise it to the power. So now we have x plus 2 equals 4 cubed. 4 cubed is 64. Then we can subtract 2. So therefore, we know that x equals 62. Then you could plug it in. Now, just to practice plugging it in. So this is 62 plus 2. And then it's raised to the 2/3. Let's do it for now. Does that equal 16? So remember, this is cubed root of 64 raised to the square. Cube root of 64 is 4. And 4 squared is 16. And so this works. So our answer is x equals 62. So here are some examples here. Try these 3. And they're similar to the other one. Okay, trying this out. Number 1, you should have gotten x equals -9, and then you plug it in. Again, I rewrite it as an nth root. It's just so it's nicer to see, something that we might be a little more used to seeing. So cube root of negative 27 is negative 3, so that's true. Number 2, I raise it to the second power, and then I set it equal to 0, x squared minus x minus 6. Then it's factorable, x minus 3 times x plus 2. So x equals 3 and x equals negative 2. I check and I see that only 3 works, negative 2 does not work. And again, rewriting it, so x plus 6 to the 1/2 is really the square root of x plus 6. Number 3, we're going to raise it to the 4/3, so it's nice to kind of rewrite it. And then so we have x plus 2 equals 8 to the 4/3. And so we know x plus 2 equals cube root of 8 to the 4th power. And we can evaluate that. Cube root of 8 is 2, and then now 2 to the 4th is 16. So we solve, and so we see that x equals 14. We plug it in. Good to plug it in. Good practice to remember how to evaluate these. So it's the 4th root, right? The denominator is the index. 4th root of 14 plus 2 raised to the 3rd power equals 8. 4th root of 16 to the 3rd power. So 4th root of 16 is 2. 2 cubed is 8.